If this is the first time that you are visiting our channel, please make sure you hit the subscribe button.
Have you ever wondered where geothermal energy comes from and how it's used? Our planet is a powerhouse, literally. The Earth's internal heat is the origin of geothermal energy. This heat comes from two sources, radioactive decay and the residual heat from the planet's formation. It's like a giant natural nuclear reactor that never stops. Now let's dive a bit deeper, beneath the Earth's crust. There, in geologically active areas, we find geothermal reservoirs. These are naturally occurring pockets of hot water or steam tucked away in regions such as volcanic landscapes, geothermal hotspots, and even along tectonic plate boundaries. It's like the Earth's own version of a hot tub, but with a lot more power. This vast underground network of heat is the foundation for geothermal power generation. So now that we know where geothermal energy originates, how do we harness this power? Harnessing geothermal energy isn't as complex as you might think. It all begins deep beneath the Earth's surface, where hot water or steam reservoirs exist naturally in geologically active areas. These reservoirs are the starting point for geothermal power plants, which convert the Earth's heat into usable energy. Let's start with binary cycle plants. Here it's all about a closed-loop system. Hot water or steam from the underground reservoir is passed through a heat exchanger. This heat is used to vaporize a working fluid such as isobutane or isopentane, which has a lower boiling point than water. The vaporized fluid then drives turbines connected to generators, producing electricity. Once the fluid has done its job, it's condensed and reused in the cycle, making the process highly efficient. Next, we have flash steam plants. These plants harness high-pressure hot water from the reservoir. The hot water is released into lower-pressure tanks or separators, causing the water to flash into steam. The sudden steam surge drives turbines and generators, transforming mechanical energy into electricity. And then, there's dry steam plants. These plants operate in areas with high-temperature steam reservoirs. They directly extract steam from the reservoir to drive turbines and generate electricity, skipping the need for vaporization or flashing. It's a simple yet powerful process. In all these types of plants, the end goal is the same: to convert the Earth's internal heat into electricity. Each plant type has its unique way of achieving this, using the principles of thermodynamics to make the most of the heat stored deep within the Earth. But, while these methods are fascinating, it's worth noting that they're not the only ways to harness geothermal energy. But electricity generation isn't the only use for geothermal energy. Beyond lighting up our homes, geothermal energy has some direct uses too. One of the most common applications is heating buildings. By using geothermal heat pumps, the stable temperatures of the Earth can be leveraged to heat homes and offices, even on the coldest winter days. This renewable heat source is not only efficient, but also decreases our reliance on fossil fuels. On a larger scale, geothermal energy is used for greenhouse agriculture. The constant warmth from the Earth can create an ideal environment for plant growth, allowing for year-round cultivation, irrespective of the weather outside. In industry, geothermal energy is harnessed for processes such as drying and desalination. It offers a sustainable solution to power these energy-intensive operations. Finally, spa and wellness facilities have been utilizing geothermal heat for centuries. From the Roman baths to modern-day hot springs, the therapeutic properties of geothermal waters are well known. Geothermal energy seems like an excellent solution, but are there any drawbacks? Like any energy source, geothermal energy has its pros and cons. On the upside, geothermal power is renewable and sustainable, with the Earth's internal heat continuously replenishing the energy source. It's a low-emission power source, producing minimal greenhouse gases compared to fossil fuels, and offers local economic benefits through job creation and energy security. However, there are also challenges to consider. Geothermal power generation is largely dependent on location, being limited to geologically active areas. Over-extraction can lead to resource depletion and reduced energy output over time. There are also environmental impacts to consider, such as land disturbance and water usage. Moreover, the initial investment costs for setting up geothermal power plants can be quite high. Pioneers in geothermal technology are constantly working to mitigate these challenges and maximize the benefits. These trailblazers are pushing the boundaries of what's possible, transforming the way we harness Earth's internal heat. Despite the challenges, the potential of geothermal energy is vast, and its role in our energy future is undeniable.
If you want us to make this kind of video, make sure you comment below and do not forget to subscribe.